Okay, now what will we record? Let me go again to the PowerPoint. So I'll show you exactly where you do this. Okay, now that's the wrong class. I don't know why I opened that one. Here's the one we are in, Physical Science 111, 10689, Physical Science. Okay, now, so let's open it up there. Okay, come here to the content. That's where we are. Oh, it's not zooming? Okay, let me get zoom. I sometimes can't tell as well on this side. Okay. There. Content, Google Chrome. That's where we are. Okay, can you see that now? Okay. Got it. I can't get I have a toolbar, taskbar that's in the way here. Even though you can't see it, that's what's being recorded on my end, so that would be blocking whatever anyone was trying to see. I think for right now I'm going to move, and you can't see this either, but I'm going to move those of us who show up on this bar here up on top. Okay, that way I can get to my scroll here. So what I'm going to do is go down here. Whoops, I went too far. Yeah, here it is. You see weekly assignments, activities. Again, you can't click on this because there's no icon. So come to the arrow on the right. It's pointing downward. Flip it till it goes up. And then we're going to week 4 because that's where we are right now, week 4. Okay, I'm going to click on that. It'll take its time opening. Well, sometimes these things you have to double click. Others, if you double click, they open and close real fast. So that time I double clicked and I should have just single clicked. But anyway. Okay, instructional materials. This is where we go. Week 4 instructional materials. Click on that. It has an icon underlined so you can click there. Okay, here we are, Lab 5. Now again, you have an icon but no underline here. So you come over to the 3 dots on the right, and that's where we'll click there. It says download the original file, so I'm going to click that. And then over here in the lower left corner, you see it's downloading right now. Now it's downloaded, so I'm going to click on that. I just realized I need to put something else out here for you. And I had forgotten about this because you see when I used to have it set up before they went to these templates, I had a thing here. I've got to pause just a moment here. Sorry about this. And do some manipulation here. I've got to put something else out there for you. So I'm going to minimize this, so we're going to lose it for a moment here. And I'm going to minimize, well, no, I don't want to minimize that. I want to go to physical science that I taught this summer. And I keep having to move y'all out of the way. Okay. Don't need that. Sorry, this is going to take just a few minutes. Okay. Physical science 111 summer, that one right there. Okay. Yeah. It's called laboratory simulations. Okay. I'm going to open that. Now I got to move y'all out of the way again. This is so awkward. Okay. Here's what I want to load. PH. Okay. So I'm going to copy this. Okay. And go back to content. Okay. Maneuvering around Blackboard is never easy and it's never fast. Okay. So move y'all again. This guy, I'm going to go back to weekly activities and assignments. Yeah, I can't click. I always want to click on that and I can't. Week 4. Okay, is that somebody else coming in or did I just happen to go by that? Let me check. Nope. Okay. So week 4, instructional materials, lessons, blah, blah, blah. Okay. Now, I have to edit this whole thing here and go web link. See, I probably should have done this first. Wait a minute. Need to be right here. Now do a web link. Put the URL here. There we go. And insert there. Wow. Okay. Now I'll save that. And go back to, can y'all see this now? Instructional materials? Okay. Were you able to watch everything I was doing there? When I went, okay, all right, well good. I thought it would lose you, but it didn't. Sometimes it does, sometimes it doesn't. All right. So here's the two things you need. You need this one and you need this. Now, I don't know which order it really matters. Let me go on and click on, let me open this first. Okay, so again, click on the 3 dots, download original file, and when it finishes uploading, I'm going to open it. Okay, here's the lab that we will be doing. Now, I got to get y'all out of the way again. And Darius, you're in the way again. No, Christian is. Okay, let me scoot you over here. All right. Now, screen sharing is paused. Let me get back to screen sharing. This is so awkward. Actually, I can do away with this one. I didn't know that was already open. Well, who cares? Blackboard, Google Chrome, I think that's the one I want. Yuck! Why did it do that? I have to log in again. This is nuts. We were just there, and now it says I have to log in again. And I have to go back. I have a lot of courses I've taught in the last 3 terms. There we are. Open this again. And good, I got to go through all this again. They just make this so stinking awkward. Now I got to move y'all out of the way again. And go back to week 4. This is so incredibly slow. Alright, move back down here again to instructional materials, lesson plan, and PowerPoints. And this time I'll open the link. You see the link here, https:// .colorado.edu/en blah blah blah. I'm going to open that. Alright, now this is what your instructions, if anyone's printed off your PowerPoints, I'm going to have to go back and forth between the two, so here we go. Here's the lab. I don't see where my other one was, but hopefully we can find it. Okay. It says go to Blackboard for this course. Okay, I need to probably change this for week 4. And click on content, well, blah, blah, blah. Go to laboratory simulation. So I've got to change a little bit of this. I'd forgotten this. But anyway, that's where I have. I pulled up the laboratory simulations, click on it. When it opens, click on simulations. So I'll show you that. Under Earth Science, scroll down till you see plate tectonics. Click on that. And when it comes, when you see it come up with an arrow in the center, click on the arrow. So hang on to all these thoughts. Click on the download at the bottom of the left corner of the screen. Maximize the screen. In the view box, blah, 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 click on both and show labels. You'll see what I'm talking about in a minute. In the My Crust, that's why it's good for you to have this printed off, so there's the instructions and you don't have to go back and forth. In fact, I probably do have it printed off somewhere, so why don't I get that? Hold on just a second. No, I don't have it printed off. I did, but I think it got mixed in with stuff that I recycled or trashed or had shredded or whatever. So I don't have a copy of this. I could print one right now, but I think it's just as easy. So we'll go through all this. Okay, the both and show labels. You'll see what I'll talk about. In the My Crust box in the upper left, increase the thickness until it matches the continental crust on the right. Blah blah blah. Move to the composition gauge to match the color of the continental crust. Okay. Now, we're going to do that on the thing, and then we're going to answer these questions. So, let me go back to, and the thing that was disconcerting here, I don't know if this is it or that's it. I wish they'd showed me what it looked like. Let me try this one. No, that's not it. Let me try this one. There it is. Okay. So I got to move y'all out of the way again. All right. So here's what we were talking about. We got to PHET. So here's what we got. Go to simulations. You see where I am on simulations? Can y'all see this? Yes. Okay. Go down to Earth Science. You see Earth Science there? Yes. Okay. Click on Earth Science. Okay. You got here through that link on that I just put in there. Now what we're looking for is, I'm going to move y'all to the top again so y'all can read all this. So I can read all this. You don't see that, but okay. Now we're looking for plate tectonics. Okay. It's pretty much alphabetical. So let's just scroll down. Ooh, getting close. Here we are, plate tectonics. Okay. So we'll click on that one. And then when that comes up and you see the arrow here in the middle, you could do download here. This takes you straight there. Click on that. And you'll see it's loading down here. Now it says this type of file could harm your computer. It never has, so I'm going to keep it. Still loading or downloading. Why is it taking so long? I don't know. I don't think it's through yet. There it is. Now it's through. So click on it in the lower left corner. Can you see this? Okay, good. So I'm going to click on that. And here it comes, slow but sure. Okay. Well, this is where I said maximize your window. So I got to move Christian out of the way again. Okay. Now, maximize the screen right up here. You know how to do that. Maximize. There we have the screen. Okay. Now, y'all are in the way again. Okay. Yuck, where can I put you? Okay. Right now we're on crust, and that's where we stay. So I think I'll move y'all over to the other side because all of our other things are on this side. Okay. So, that's not where I want you. Come down here. There we go. What? Okay. Now, it's still somewhat in the way, but let's see if I can move you up just a little bit. Okay, I don't want to move you too far. Okay. Now, is this someone trying to... Oh, screen sharing is paused. Yuck. See if I can get this back again. I thought we were here. That's it right here, I think. Okay, we're back. Can y'all see that now? Yay or nay? Yes. Okay. Now, I'm going to... Does anyone have the lab part printed? So I don't have to go back and forth, but I can. It just, you know, it takes a longer time. Remember on the thing it said we want to do both, and this is the both it's talking about down here. You see it? View, density, temperatures, or both. We want to show both. There we go. Now, there was something else I was supposed to click. I'm trying to remember what that is. Let me go back and look. Now this is going to take a while. Notice how slow things are moving now. I don't know if you can see it. I can. I mean, this is inching along. I've got too many things open, but let's do it. Okay. All right. So we've done all this, clicked on download, blah, blah, blah. In the view box in the lower left corner, click on both and show labels. I didn't do the show labels. That's the part I was doing. In the My Crust box in the upper center of the screen, increase the thickness of until it matches continental crust thickness on the right, and move the composition gauge to match the color of the continental crust. Okay. So let's go back here and do what they said. We're looking for, what was that first thing? Show labels. That's what I'm looking for. So go back here and go back here. All right. Where is show labels? Oh, down here. Okay. All right. So click on both and show labels. All right. Now we see. Here is the continental crust. This is my crust. This is the oceanic crust. Okay. Now, what we're going to do, we want to match my crust to the continental crust. And if my memory's right, here's how you, let's see, did it say zoom? No, that's not it. Wait. My Mari must have gone out and come back in. Okay. Oh, composition. This is the one we move. We adjust this composition until we get, okay. Okay, I guess the first thing we do is thickness. Okay, you see when I'm moving this, you see what's happening? My crust is growing thicker. I'm going to try to match the continental crust. Okay, not quite matching, so I'm going to do my composition to see what I can do here. Here I'm going for color. That's getting darker, that's getting lighter. Okay, still need to adjust the thickness a little bit. Okay, it looks like I have a pretty good match there. My crust is the same as continental crust. The first question asks, what is the composition? Is it more toward iron or more toward silica? Can you see? Perfect. Way to go. That was the first question, right? Okay. All right. This is slow as molasses here, folks. Okay. All right. First question. Is the gauge nearer the more silica end or the more iron end? It was near the more silica end. Now it says in the toolbox, and we'll go back and find the toolbox, in the lower left of the screen, we'll see that, move the ruler to measure the thickness of the continental crust. Okay? And then we will estimate that thickness here. So that's what we fill in next. So let's go back to this. Let's go down to the toolbox here, take the ruler out, and move the ruler over here until we are, put 0 at the top. All right, that looks about it. What would you say? That's about 45 kilometers thick. Agreed? Okay, 45 kilometers, just to give you an idea. Okay, I'm going to turn on my calculator real quickly here. I don't do anything very quickly. 45 kilometers is about 27 miles. 27 miles thick is the continental crust. Okay? That's pretty thick, wouldn't you say? We've never been through that as far as I know. That's 27 miles down. That would be further than from Birmingham to Bessemer, but going straight down. Okay? Whoa. All right. Now, let's see what the next, oh yeah, I think, well.
It says move the thermometer from the toolbox
to okay.
Okay,
you see the thermometer here in the toolbox? Put your cursor on it, pick it up, and move it here to the upper part of the crust. Okay, now the trouble is we don't have any real gauge on the thermometer. So I'm just going to let you know, let's just call that 20. Remember that, we'll just call it 20. We'll call this one down here 10, that one 20, that one 30, that one 40, that one 50, that one 60, that one 70. It doesn't work out exactly, but that'll be it. Just so let's call it 20. And that'll be 20 degrees Celsius. The reason I called it that, that's near room temperature. Okay? Now what does it say do next?
move the thermometer to the lower part of the crust and estimate the temperature there.
Notice what's happening to the temperature. It's going up. Okay, it went up to near, and again, we're just using a relative scale, about 30 degrees Celsius. So it's hotter down there. Well, I've never been 27 miles down. I don't know that it is, but it is. Okay? What's the next question?
Move the density meter from the toolbox to the crust and estimate the density there.
Okay, you see the density meter over here in the toolbox? I'm going to click on it and go over here to the crust, and let's see, does it make any difference whether you're in the upper part of the crust or the lower part of the crust? It doesn't seem to make a lot of difference. So we'll just do anywhere in the crust here, and let's see, what's the density meter? All right, again, let's just do relative scale. Let's call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 7.75 or 7.5. Let's call that 7.7 maybe. Density. It's just a relative number. 7.7. You okay with that? See, I was calling this 1, 2, 3, 4, 5, 6, 7. That would be 7.5. Let's just call that 7.6, 7.7. It's just a relative number. Okay, whoa. Jackson, raise your hand. What you got? Did you have a question, Jackson? Okay, I don't hear Jackson. Do any of you hear Jackson? Oh, you got it? Did you have your hand up? What you got?
I didn't get those two temperature
Okay. Okay. Let's go up here, move the thermometer to the top up here. And again, we're just using a relative scale here. Let's just call that 10 and call that 20. Let's call it 20 degrees Celsius. I don't know if that's really what it is. That's near room temperature. Seems like a good place to start. We really don't know if they're degrees Celsius. They're just, you could just give the number 20. Move down to the lower part of the crust, continental crust, and now you're up to 30. 10, 20, 30. You can put degrees Celsius if you want to, or just leave it 30. Because I don't know if it's actually in degrees Celsius or not. Okay, does everybody have the density one? All right. 7.7. And what's what?
The one that says move the thermometer to the lower part.
Yeah, that's where we are right now, and isn't that right around 30? We're just using a relative scale. This was 10, that was 20, that was 30. Up at the top, it was right at 20. Up here, down here, it's 30. Again, it's just a relative scale. You could call it degrees Celsius if you want to. I don't know if that's the scale they're using. You could if you wanted to. Okay. Any other questions? Okay, what does it say do next?
Increase the thickness of the crust until it matches the oceanic crust thickness on the left.
Okay, you see the oceanic crust over here? There's the ocean on top. We're looking at this. So we're going to decrease thickness until we're close to the same as the oceanic crust. Okay, that's close to the same. Now we have to move composition until we get the same color approximately. Do you see we're getting closer? Need to do thickness just a little bit more. Whoops. I think we're really there, don't you? Okay. Now what does it say to do with that? I think the first...
Is this gauge near the more silica end or the more iron end?
What do you say? Let's look at the composition under my crust.
Looks like
Yeah, looks like it's a bit closer to iron. Certainly closer to iron than it was here. Okay? So it's more iron. Okay? Next question. Is that thickness?
use the ruler to estimate the
Okay, so let's go down here. So we get the ruler right at the top of that. And what would its thickness be? Oh my goodness. This would be 10 kilometers. That would be 5. What would you say? Maybe 7? Yay or nay? Okay, about 7 kilometers. 7 kilometers would be about 4.2 miles. So even the oceanic crust, which is so much thinner than the continental crust, is still about 4.5 miles thick. Man, that's thick. Okay? Now, what's...
Move the density meter to estimate the density of the oceanic crust and record it.
Okay. Right around there. And what are we there? There's 1, 2, 3, 4, 5, 6, 7, 8. Looks like about 8.5, doesn't it? We don't know what units, but about 8.5. Now you tell me, is that denser or less dense than the continental crust?
4.
More dense, for sure. Excellent. Was that a question or did I just throw that in?
The question was which crust appears to be denser.
Oh, okay. Can you answer that?
Yes, the oceanic crust.
Oceanic crust. Very good. All right. Good deal. What's the next question?
Also, which crust appears to be thicker.
Okay. I think I know the answer to that one. Continental, right? Yay or nay?
Yes, sir.
All right. Good deal. What's the next question?
What is the name of the boundary between the crust and the mantle?
Okay. Good question. This is from your text. This boundary right here between the oceanic crust and the mantle, here's the mantle down here, or it's the same as this boundary here between the continental crust and the mantle. Now, there's no breaks like you see here. They're much smoother than this, but still, what is that called? You'll need your book for this one, especially for the spelling of it. Does anyone remember? The Moho, remember that? The Mohorovicic discontinuity. You'll need your book for that. Let me get your book, my book. And this is in chapter 18, remember, not 19. Okay. All right. On page 461 or 18-4, right under the crust, the first paragraph talks about the crust. The second paragraph says the boundary between the crust and the mantle is marked by a sharp increase in the velocity of the seismic waves as they pass from crust to mantle. Okay, usually they go the other way. Today, this boundary is called the Mohorovicic discontinuity, or the MOHO for short. If you want the spelling, here it is again. M-O-H-O-R-O-V-I-C-I-C. Mohorovicic discontinuity. D-I... Okay. I don't have it in front of me. Do one of... Okay. Mohorovicic discontinuity. Exactly. All right. Any other questions? Great time to ask them. We're all here together. Labs are a community event. We're doing it together. What's the next question? Anybody? Okay. Here's the thermometer. I'm going to move it to the upper part of the mantle. And what would you say the temperature is? We were calling that 10, 20, 30, around 40. Whatever. You can call it degrees Celsius if you want to, or just call it 40, because it's just a relative scale. Was that a little warmer than the bottom part of the crust? Or is that the same? Warmer, I thought so. Was that a question or did I just throw that in?
I think you just threw that one in.
Okay, that's fine. I just don't have it in front of me. I'm just helping you point it out. Next.
Move the density gauge to the upper part of the mantle and report the density there.
Okay, move it to the upper part of the mantle, right about there. And what do we read? There's 10, 20, 1, 2, 3, 4, 5, 6, 7, 8.3 maybe? No, 8.2. Would you agree with that? Okay. And let me guess again. A little bit denser than the lower part of the crust? Or the crust? Yeah. Okay. What's next?
Go to the zoom adjustment in the upper right of the screen.
You see it up here? Yeah. And do what?
Yes, increase the zoom until the lower mantle shows and the ruler goes to it.
So I'm bringing it down. I'm trying to get to... Oh, there's a lower mantle. Okay, okay. I think somewhere right in there. All right, what are we to do now?
What is the boundary between the upper and lower mantle called?
Okay, another good question. That comes from your book again. Okay. If you got your books open, page 460... I was going to say 462, but I don't see it on here. I think I've gone too far. 463. Now, I know it's in the text somewhere here, but I can't quite see it. But I do see on the figure, you see on 463 that figure, 18-0.7. Oh, here it is. It's on the figure 18.7, but if you flip over to 464, there it is. First paragraph on 464. The important part of this different structural description of the Earth's interior was first identified from the seismic data. There is a thin zone in the mantle where the seismic waves make a sharp decrease in velocity. This lower velocity zone is evidently a hot, elastic, semi-liquid layer that extends around the entire Earth. It is called the, anyone with me? Asthenosphere. A-S-T-H-E-N-O-S-P-H-E-R-E. And that actually means, in the Greek, a weak shell. Okay, for anyone who's interested in that. Asthenosphere. I don't know for sure if I can write on this screen. I'm going to try to, because those are sort of tough words to spell. Let's see if we can get that. Will this? No, I don't think it'll let me write. No, it won't let me write. So if I need to spell it for you again, I will, or if the page number is adequate, I'll leave it as a page number. Does anyone need it again? Okay. Asthenosphere. A-S, let's see, is someone else coming in the class or did someone just leave? I don't see it. What's that?
They wrote the spelling of asthenosphere.
Okay, where do they write that?
In chat.
Oh, in chat. Excellent, excellent. Do y'all see it there? See, I've got so many things open now, it's hard to even look at chat. I don't have enough room on my screen. Do y'all see it, or do you need it again? A-S-T-H-E-N-O-S-P-H-E-R-E. Asthenosphere. It's for the Greek for weak shell. Sphere basically a shell, and azimuth mean weak. Okay, what's the next question?
What is the distance from the surface to this boundary?
Okay, surface to the boundary. Okay, so I'm going to take my ruler here, click on it, and go from the surface. I'm going to do the surface being the continental crust here, because it's sort of handy right there. Okay, I'm pretty close to it right there. How many kilometers? 100 kilometers, 2, 3, 4, 5, 6, 7, 8, 800, oh wait, no, 750 kilometers? 750 kilometers. I'm going to pull out my handy dandy calculator again and see what that gives me. What did I say, 750? That's about 450 miles thick from the surface to the asthenosphere. I'd say we've never been there, wouldn't you? I know I haven't. I don't think anyone could get there. I don't think equipment could make it down that far. Okay. What's the next question?
What is the crust in the upper mantle called?
Ah, when you combine the crust with the upper mantle. Here's the crust up here. Combine that with the upper mantle down to here. What is that called? If you're still on page 464, there it is in the next paragraph after asthenosphere. It says the rocks above and below the asthenosphere are rigid, lacking a partial melt. The solid layer above the asthenosphere is called the lithosphere. Lithosphere. And that's after the Greek for stone shell. So litho means stone. Lithosphere. Say again? Okay. Lithosphere. Lithosphere. Someone put that on chat? Okay. All right. Good deal. Any other questions? All right. What's the next one?
What is the approximate thickness of the upper mantle?
Approximate thickness of the upper mantle. Okay, so what I'm going to do is bring the ruler down here to the bottom of the crust, and that looks like right around 700 kilometers. Now, if we went over here to the bottom part of the oceanic crust, it's closer to 750. So it's between 700 and 750. Because remember, the oceanic crust is really, really thin. So it's something between 700 and 750 kilometers. Okay. And you can put the range there. You can just use the continental crust or whatever. Everybody got it? And remember, y'all can go through and play with this too and answer it on your own. I'm just showing you how to do it. Yes?
Will you repeat it one more time? I'm sorry.
What, the thickness of the upper mantle?
Yes, sir.
I would say between 700 and 750 kilometers. Because if you go it from the bottom of the continental crust is so much thicker, it's right at 700 kilometers. If you go from the bottom of the oceanic crust, then you're right at it may not be 750, let's call it 740. So 700 to 740 kilometers. You can put the range there, you can choose either one of the numbers, it doesn't matter. All right. Any other questions? Okay. What's next? See the temperature.
It's move the thermometer to the near to near the boundary in the upper mantle and record the temperature there.
Okay, so I'm going to move the thermometer down here. Now notice what's happening when I move. It's going up, 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 okay, till near the boundary in the upper mantle. Is that what you said? So let's stop right about there. Okay, and what's our temperature there? We were calling this 10, 20, 30, 40, 50, what, maybe about 52. Again, relative scale, I don't know what it is, but let's say around 52. Do we do the same with the density? What's the next question?
Move the thermometer to the upper part of the lower mantle.
Okay. All right, so I'm not going to move too far, just a little bit here. Okay, and there it's 10. Wait, did someone just come in or did I do that? No, I don't think anyone else is coming in. Okay, so this is 10, 20, 30, 40, 50, looks like maybe 52, 53. So it's not much difference, is it? Now, it looked like somebody was, maybe y'all are sending chats, I don't know.
Yes, it's just chat.
Okay, good. I just want to make sure nobody else is coming in. I don't want to leave anybody out. Okay, so it looks like about the same. Maybe 50, maybe one whatever it is more, something like that. Okay, next.
Move the density meter to the lower part of the upper mantle and record the density there.
Okay, density meter. Now look what's happening to the density meter. So we go down, it gets more and more and more, and suddenly it reaches, oh, look at that. So what we were calling units there, we've now gone to the upper part here. I can't show it to you. Right here, that means we've reached 10. We were calling that 0 to 10. So now what we're going to read here is anything plus 10. So the density is going up, 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 up. Let's stop right about there. So that would be 10, 11, 12, 12.6 maybe. Again, it's a relative scale. Is that what y'all see it as? Anybody?
I agree.
Okay. So we'll just hold it at 12.6. Again, relative. It could be a log scale. We don't know, but just a relative scale. What's next?
Increase the zoom to the outer core and expand the ruler.
Okay.
From the crust to the outer core.
Okay. So I'm going to go up here to the upper right. You see the zoom. I'm going to make it go down, and we're going to look for the outer core. Oh, there it is, until we get the ruler to show that, right? Now, what do we do next?
Record the distance from the crust to the outer core.
Okay. So I'm going to try to do that right here, bottom of the continental crust. And I would say this is in kilometers. That's 2,500. That'd be 2,750. What would you say, about 2,800?
Okay, I was giving it 2,750. Okay, yeah, you're right.
Okay, it may even be more than 2,800, but let's call it that. It's a relative scale, and that's kilometers, by the way. Now let's see if it makes any difference if we do it from the oceanic crust. I doubt if it makes much difference at all. It looks like the bottom of the oceanic crust. And now we're at 20, this would be 2750, And that would be maybe, no, this is 2750. That may be closer to 2900. I don't know. 2850 maybe. That would be a good compromise. 2,850 kilometers. You think anyone's ever made the journey to the center of the earth? No. Okay. So anything right in there will do. What's next?
Or the approximate thickness of the mantle.
Okay. I thought that's what we just did. Maybe it meant, read the previous question.
The previous one, once you increase the zoom to the outer core and expand the ruler, it said record the distance from the crest to the outer core.
Okay. And then the next one says the approximate thickness of the mantle. Well, isn't that the same answer? I don't know what I was thinking when I wrote this.
The mantle looks like it's closer to.
Oh, does it say outer mantle or just mantle?
Just
Okay.
mantle.
On both those questions.
No, the first one is outer core. The second one is the thickness of the mantle, and then your third question is going to be the thickness of the lower mantle.
Okay. All right. So read me the first of those questions again.
Record the distance from the crust to the outer core, which is what we just did, right?
Right.
Now we're going to record the approximate thickness of the mantle.
Well, that's the same answer, isn't it? From the crust to the outer core, that is the mantle. So just write that one down again. Okay, I'm sorry. I must have been thinking about something else when I wrote the.
Yeah, when I was reading the question, I was like, well, I think they're about the same.
They are. I think they are. Yeah, I believe you're right. Sorry about that. Okay, and then the next question.
Record the approximate thickness of the lower mantle.
Lower mantle. I can do that. Okay, put your cursor on the thing and go from the lower mantle here to the outer core here, and that looks about 2,200, because this would be 2250, so that would be about 2,200 kilometers. Would you agree? All right, 2,200 kilometers. Thickness of the lower mantle, right? All right, what's next? Okay. What's next?
Move the ruler back to the surface and move the thermometer until it reaches.
Until it reaches what?
100.
100. Okay. Oh, we're going to the surface.
Yes, we're going to record that depth.
Okay, got it. Okay. Now, we're going to do the thermometer till it reaches 100. Now, what I'm calling 100 is when you get the next scale, when it jumps up a scale. I don't know if that's 100. Oh, there it is. What depth would you say that was? About 1,200 kilometers. This would be 1,000. This would be 1,250. So that would be about 1,200 kilometers, 1,200 kilometers. You see, that popped up here. So I'm just saying that's 100. I don't know if that's what it means, but let's just say that. Okay? Agreed? Okay. What's next?
Region are you?
Which region are we in? I know everything's sort of in the way there. This little line right here separates the upper mantle from lower mantle. So we're in the lower mantle. Right?
So we're calling this region lower mantle.
Yes. Or we could call it hot. No, I'm just kidding. We wouldn't call it that. Okay. What's next?
Move the thermometer until
Okay, let's watch me do it. See, it's going up, 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 up. Whoa! Right about there. Let's call that 2,500. This will be 2,750. So let's call that 2,700. 2,700 kilometers. It's still lower mantle. See, lower mantle is still right there. My ruler's on top, but that's still lower mantle. We're not yet in the outer core. What's next? What's next?
What is the temperature in the lower mantle just above the outer core?
Okay, let's move it down a little bit further till we're just above the outer core. I guess that would be close enough. Looks like about, that would be 200. You want to call it 220, or let's call it 218 or 219. Something around there. I'm just making up. It's a relative scale anyway. 218, 219, something just below 220.
What is the temperature in the upper part of the outer core?
Okay, let's skip down just a little bit further. Whoa! Did you see what happened there? It went up to 231 or 2. So you had a pretty big jump in temperature there. Not a huge one, but pretty good size.
What is believed to be the phase of the outer core?
All right. Do you know what we mean by phase? We usually say there's 3 phases of matter. There's really 4, but we'll say 3. Most rock is solid. What's the next one? Liquid. That's what the outer core is believed to be. The mantle, solid as a rock. Okay, that's rock. The outer core we believe to be liquid. Remember the seismic data? The P waves do not go through a liquid, so they have a huge shadow zone which defines what the outer core is. The S waves, I hope I said S waves. The P waves, they will go through liquid, and they go right on through. They do have a shadow zone, but it's small. But the S waves, they don't go through liquid at all, and that's a huge area. None of the S waves go through at all. So we know, or we suspect, that's a liquid. And that's how we know about the size of it too. Were people still sending messages, or chats, or was that someone trying to get in the room? I don't see anyone trying to get in. Chat, good deal. What? I couldn't hear. What did you say?
What's the phase of the outer core?
Okay, what was it? Anybody? Liquid. Yeah. And our seismic data told us that because the S waves do not go through a liquid, and you don't get any that pass through that region. The P waves do go through liquids, and you do get them coming through. So that's why we figure that's a liquid, and we know about what size it is because of that shadow zone that's formed. What's next?
Move the density meter to the lower portion of the lower mantle and record the density there.
Okay, so watch me move it. I'm going to move it on this side. And the density is going up and up and up and up and up and up and up. Now remember, whoa, I went too much. Oh, man, there was a jump there, wasn't there? Okay, that is, remember, this was 10, 11, 12, 13, 14, 15. Let's just call it 16.
Move the density meter to the upper portion of the outer core and record the density there.
Okay. Everybody got the previous one. Now watch this move. Move it just a little way. Whoa, look at that. Now we went up to 20 and it went all the way over here. So that's 10. No, I mean 1, 2, 3, 4, 5, 6, 7, 8. 28.7? Wow, what a jump. 28.7. Huge density increase. And that's a liquid, okay? It was solid, now it's liquid. That's a big change. Next.
Expand the zoom to the max and move the ruler to estimate the thickness of the outer core and record it.
Okay. Gonna move the zoom all the way down. We're zooming while we're zooming. Okay. Now move the ruler and we're going to estimate the thickness of the outer core. Now you see the inner core here. So let's move the ruler down to estimate the thickness of the outer core. Now the trouble is I can't go from top to bottom because it won't. Well, it will. Look at that. It will. So let's go outer core to there. That looks about 2,000, that's 2250. The thickness of the outer core appears to be about 2,250 kilometers. Oh my word, that's the outer core. Yo! Everybody got it? Okay. What's next?
Estimate the radius of the inner core.
Okay. Let's see if we can estimate that radius. See if we can get this to go further down. I think that's where we run into problems. No, we don't. I just didn't have the thing there. Okay. So that looks about 500, 1,000. That would be 1250, maybe about 1,200 kilometers. That's an estimate. About 1,200 kilometers, approximately. Okay. Is that more chats or anyone coming in? Okay, good deal.
Last one was 1,200 kilometers. That's number 33.
Yeah, about 1,200 kilometers. That's the estimate. Okay. What's next?
34. Move the thermometer to the lower part of the outer core and estimate the temperature there.
Okay, here we go down, down, down.
32 is 2,250.
Who was saying that? I mean, who?
Question asked, and I can't chat and read and type.
Okay, I see. Okay, there we are in the lower part of the outer core. So we were calling that 200, 10, 20, 30, 40, 50, 60. I would maybe even make that 80. 280 whatevers, you know. They're probably not degrees, but 280s. Okay. So it keeps going up, doesn't it? What's next? Wait, I'll let y'all get caught up. I take it these are all chats.
Yes, sir.
Good.
Number 35. Move the thermometer to near the center of the inner core and estimate the temperature there.
Okay, to near the center of the inner core and estimate the temperature there. That's pretty much it. It didn't seem like it changed a lot. That I might say 290 now, but not too much beyond that. So it's still incredibly hot, okay? Whatever the scale is, it's not degrees. I can guarantee that.
Number 36.
I don't know. What is it next?
Move the ruler back to the surface and the density meter down in the outer core until you exceed 300.
Okay.
From the surface there.
Okay, we're going to move the ruler back to the surface. Okay. And see, the ruler only goes so far. And that's all we got. Okay. Move the density meter until it reaches 300. See, it's 290 now, so it's not going to be much further. Whoa! Right about there, wasn't it? Right there. Let's see what that is. This was 2,000, 2,500, 3,000, 3,250. Let's make it 3,260. No, that's not right. Yeah, I'll make it 3,300. 3,300 kilometers. It's estimate, it's approximate. Would you agree with that? Looks about right, doesn't it?
Yes, sir.
Less than 3,500. It's about 3,300. Okay?
And number 37.
Okay.
Meter to the lower part of the outer core and estimate the density there.
Lower part of the outer core. That would be right around there. Right? The density, that's 300. Wait, 3, I'm sorry. 1, 2, 3, 4, 5, 6. No, wait. 30, I'm sorry. 30, 1, 2, 3, 4, 30. 1, 2, 3, 4, 5, 6. And a half. 36 and a half. What were we calling the thing above it, the previous question? Till the density meter exceeded 3? Read me the question just before that one.
It was move the ruler back to the surface and
Right.
the density meter down in the outer core until you exceed 300. Estimate the depth from the surface.
Okay. That shouldn't be 300. That should be 30. I'm sorry. Shouldn't be 300. I think it should be 30. It's a relative scale, remember? And I think we were calling that 10s and 20s before, so this would be 30. So change that from 300 to 30. That's what was confusing me. Okay. And now at the lower part of the outer core, it would be 30, 1, 2, 3, 4, 5, 6, 36 and a half.
So for our answer, the number 36, would it still be 3,300, or we're gonna have to redo that one?
Okay, which one are you talking about? The one just before it? It's no, on my question part, it said 300. Change that 300 to a 30. The distance is the same. We got the distance right. It's just what the density meter was reading. It was reading 30, not 300.
The answer to number 6 is 3,300, and the answer to number 37 is 36.5.
Yeah, those were distances, weren't they? See, I don't have my paper in front.
Yes, the depth.
Yeah, yeah,
7
and the density. I just got, I went off a decimal on my density there. That should be, so the answer to the one on the density is 36.5.
And that's, okay, guys, so number 37 is 36.5.
Right. And the previous question, that should have read 30, not 300. Not the answer, but the question. When the density read 30, not 300. Wasn't that the previous question?
Yes, sir.
Right. So change that 300 in the question part, not in your answer. The question part, that should be 30. I messed that up. Okay. What's next?
We're done.
Oh, is that it? Oh, we're just beginning to have fun, weren't we? All right.
We had a system, it worked.
Yeah. Do y'all feel like you learned something in this?
I feel like I did.
Excellent.
Yeah, I feel like I learned something.
Good. Okay, that wasn't a question on the lab, but I just was hoping this was a worthwhile lab. But y'all can go to it and play with it to your heart's content. Okay? Because I was just wondering what happens to the density meter when we go into the inner core. It just keeps climbing and climbing and climbing. But I think what happened is I was running out of paper. I didn't want to do another question on another page. So I think that's why we stopped there. All right. Do y'all have any more questions about the lab? If you want anything repeated, we'll be glad to go back and do it. If you think that's got it, I hate to do it to you, but we could actually end early today. I hope you won't report me. Ah, okay.
Hey, I apologize. I forgot that was on. My bad.
Well, I don't hear well, so I couldn't make out what you were saying anyway. So.
Could we do number 8, 9, and 10?
Okay, you'll have to tell me what they are. What's
Okay, number 8 was move the density meter to estimate the density of the oceanic crust and report it.
okay? So we're going to zoom way back up at the very thing. Okay, and what were we estimating? Oh, what? Oh, density meter.
Density of the oceanic crust.
Okay, here's the density meter. I move it in the oceanic crust right about there, and I think that we were saying that's 1, 2, 3, 4, 5, 6, 7, 8.5. Is that what y'all put down for it?
Yes, sir. 8.5.
8.5. Not 80, but 8.5. Okay.
Number 9 is continental.
Yeah, what is that? Which is thicker?
Thicker. And it was
Yeah.
continental.
Yeah, way thicker, you see? And?
This crust appears to be denser.
Okay, which one seems to be denser? You took measurements of the continental crust density and this one. This oceanic was 8.5. The continental was about, wait, let me do 1, 2, 3, 4, 5, 6.
What's the denser?
Yeah, and continental crust was around 7.6. So yeah. So it was the continental crust less dense, oceanic crust denser, right?
And then I think I missed number 35 as well.
What was that one?
Move the thermometer to near the center of the inner core and estimate the temperature there.
Oh,
It was 290.
okay. Are you happy with that, or you want to see it?
You can see. I'm sorry. I'm sorry, y'all.
No, 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 no. I'm asking whoever asked it. You want to see it or just trust it? It's easy to do. Here we're down. Okay. And what was it, to the center of the inner core? Is that what you said?
Yeah, the inner core.
The center of it? Is that what we were saying? Okay. So that was, we were calling this 100, 200, and we were saying, what did we say, about 290? Okay. Every little thermometer there was 100. Every little density meter was 10. And these are just relative. You know, that's not an actual temperature, but it just shows it got hotter and hotter and hotter, denser and denser and denser. Any others? Anybody? Does that sort of help you visualize what we were talking about in the text? Frankly, it helped me, but I don't know if it helped y'all any. Okay. Just know that these scales are relative scales. No one's putting a... I said at first to put degrees on it, but then after I saw the numbers, I said, nah, it's way hotter than that. Okay, so... and also on densities, I couldn't think of any numbers that would make sense. So it's just relative scales. Now the ruler was pretty close to actual number of kilometers, but we're estimating. Yeah. So any other questions? Have the chats been helpful to you?
The chat is very useful.
Excellent, excellent. And that's what labs are all about. They're supposed to be working together as a team. So, yeah, I encourage the chats. And boy, Diana, you have a cute one there.
Oh, yes. Adorable.
Oh gosh, I got baby fever. Calm down.
All right. Any other questions? He's interested in the plate tectonics, I can tell. Okay. Any other questions? All right. Does that mean y'all are getting ready to take off for the day? Oh, I can't believe it. Okay. First thing I'm going to do is stop the sharing, if that's okay with y'all. Okay, so I'm going to stop sharing. And then, if there are no other questions, we'll end the meeting. But if anyone needs it any longer, I'll be glad to stay. Anybody? Okay. Well, then y'all have a good weekend. Yes, I have office hours tomorrow morning from 8 till 12. I haven't checked to see if anyone signed up for advising. I haven't had anyone for a long time, so I'm doubting there will be any. What's that? For what? No, if you have to sign yourself up, I can't sign you up, but there's ways to do that. I don't think it's Blackboard. I think it's the, is it My Lawson or My Lawson Campus? Some of y'all have done it before, right? How do you sign up for advising? I know there's a place out there. It's called the Virtual Advising Center. That's what you look for, and that's where you sign up. But, yeah. All right, good deal. Anyone else? Any other questions? All right.
37 is 36.5.
Okay, there was an answer to a question, I guess, on chat. Y'all got it? Did that answer anybody's question? Thank you. All right. Any others? Okay, well, I guess that means there are none, so I will end the meeting for all, but I'll say again. Oh, and by the way, I will post sometime, hopefully tonight, your Chapter 18 test. Okay? Now let me think which test. This is test 5, right? Yeah. Okay, so I'll post that. It looks a lot like the others. Test 6, you're going to find out on Chapter 19, looks quite a bit different. Okay, and I'll explain that when we get to the end of that chapter. So hopefully sometime later this evening I'll get around to posting the Chapter 18 test. That will be test 5. Okay, so 16, 17, no, 14, 15, 16, 17, 18, yeah, test 5. Any other questions? All right, be safe this weekend, folks. The virus is still out there. Be careful, be safe. And by the way, I think it's supposed to rain a lot this weekend, so it sounds like a great time to work on research papers, catching up labs and tests. Oh, wouldn't that be wonderful? Okay. Take care. We will catch you next Tuesday then, right? Bye-bye, little one. Okay. Take care.